of a field trip this morning. We're heading out to Core Switchboards in New Lynn, who are manufacturing all our new electrical main switchboards and distribution boards and components for the theatre, which are being made at the moment and going to be delivered next week. We're here at Core Switchboards in Auckland today, and we are looking at our mains electrical and distribution boards for the building getting built. This is
Darren. So I'm the production manager for Core Switchboards. So yeah, we're just doing a little tour today and show you around how the process and how we put these boards together from design stage through to final completion and testing.
So these are the switchboards in the, I guess, the final assembly step. This is where they just put on things like, the decals, the signage and the doors and get them ready to move over to the test area. We're in the final stages of the build of our switchboards. In fact, actually today is Thursday and I think they're getting delivered on Monday. So it's an exciting part of the journey. So there's two main types of boards that we're getting for St James. We've got our mains distribution boards, and we've got two inputs coming into the building. We've got a northern input and a southern input. So we have to have two main switchboards, and the main switchboards are like this. They're larger and I guess have the ability to isolate the building. And then we've got the smaller switchboards, which are like these, and they're for the rest of the building. And I think we've got about 5 or 6 of those going throughout the place. So essentially every sort of niche area of the building gets its own distribution setup. So this is one of our actual main switchboards. This is the main switchboard that will be in the stage area or the southern input to the building. And this is obviously tested, assembled on the pallet, ready to come to us in a couple of days. Whoa, whoa. We've finished the asbestos removal now throughout the whole building, so we've got our clearances, which means the site has been given back to us and we can start the restoration works. What we've done, as you can see, is we've removed all the fibrous plaster. So the asbestos was actually just sprayed onto the top. It was like a textured spray that was sprayed onto the top in the 50s. So, but to remove it, we've had to essentially remove all the cove ceilings. So we've taken mouldings of all the angles and the covings and we'll replace them. When we removed those ceilings out also, what really became apparent is how poor a condition parts of these ornate lattice work and cornice work is. And what essentially that means is that we will have to replace large chunks of it. It's just falling down. It's at the end of its life where the organic material inside of it has rotted out, it's lost its structural integrity, and it needs to be replaced. It's 100 years old. Massive milestone at St James here today. Our tools have arrived, the asbestos is out of the building, the site's back to us, and we start the physical hard work in the new year. It's Monday morning and we've come into work, and over the weekend part of the ornate cornice work has come down, and I think this highlights why we're sort of taking moulds of all the cornice work, and so we can, I guess, replace parts that have failed. And what's happened here, I guess, is you can tell when I sort of lift it up and move it that it's lost its structural integrity, and it's literally just broken off and fallen down. So what we'll do is we'll take off sections of this, probably in like a 3 metre length of it, one that's in good condition, we'll find one, and we'll fix any imperfections in it, and then we'll take a silicone mould of it, and then we'll be able to create new ones off that silicone mould, so it will be exactly what was there. And the issue with this really is that this is fibrous plaster, so there's a fibre inside it, and when they did this in 1928, they used organic fibres. So things like, they were originally horsehair, but these ones we think are coconut husk. And over the last 100 years, that organic material has decomposed and lost its structural integrity and got to the point where it's no longer doing its job of holding it together. So essentially when it gets wet or when it gets moved or it weakens itself to the point where it just falls down. So there's good chunks of the building where we're going to have to go replace it, because in some parts of the building, things like this are 20 metres above people's heads. So from a safety point of view, we've just got to replace it. Been wearing a few hats lately. Today's hat I'm wearing is that I'm the delivery driver. So we've got a bit of a difficult site in the city. It's kind of small, quite compact, and we've essentially got to be really in control about when deliveries turn up, because we've got really limited space to be able to store things. So that means we've had to get our own delivery vehicle, and here it is. And at the moment, I'm the only one with a license that can drive it, while we get some of the other team members with the correct licenses. So here I am today, picking up a load of silicone that's just arrived on a ship that we're going to use to take moulds of the ornate cornice work of the fibrous plaster in the theatre, in order to recreate that ornate cornice work where it's been damaged or removed or is just not there. And it's quite an interesting product actually. I didn't realise when we were ordering this, but they usually I'm an unusual client for this company. Usually they sell to people who make fake body parts, to put it that way. So we're out at Designer Plaster with our friend Ian here, who's doing all the fibrous plaster work and I guess ornate detailing work at the St James. And what we've got here is we had a whole lot of old mirrors and poster pin-up boards, and they had these amazing decorations on them, which were probably originally gold leafed. And what we've done is removed those now, taken them off-site, made a whole lot of repairs to them, so essentially restored them, and now we're about to pour a whole of that silicone that we just picked up into these molds to make a mold off them so that we can then recreate them from this, and they'll look exactly like they did originally. The idea is that we'll reproduce a few of these mirrors and put them around the venue. Ian, if you can just talk us through what you've the process here, what you've done, and I guess what this is, what we're looking at.
Okay, so we're looking at the sections of those large mirrors you were discussing before, and these are all the parts that were screwed around the outside of the perimeter. And when we needed to remove them, they were attached with screws that are over 100 years old, big old rusty ones, and we had to try and get in and cut them. And as a process, getting them off was quite challenging, and there's a lot of damage from previous and getting them off. So once we got them back in the shop here, the first thing we had to do was get them on these frames, clean them up, and then assess the damage. And then we had to piece them all together, glue them and screw them from the back, and then repair them so they are back to original as previously on the frame. Now that that's been done, they're now ready for the silicone pour, as you suggested.
And this one was actually in two pieces, so you've actually had to fully repair these and recarve these to...
Yes.
Wow, that's a lot of work. And to do these, I don't know, there's what, 10, 12 of them here. How long did that take? Is it a couple of days?
Oh, there's about 3 or 4 days work here in these.
Yeah.
There's, sometimes you can spend a couple of hours just carving, recarving all this through here and just getting the shapes. And like the center shield here, if you have a look at this one, all these repairs down in here and down through these curves, you had to recarve and re-nick all the little detail in there, like here to match that side there. And then right round in the base here, all that was all damaged around there. That's all got to be filled and carved and shaped at the exact same angle, so the contour follows the same angle.